7B, number 28. 7B, number 28. I did hit record, I thought. Yeah, there we go. 7B, 28. And let's see what this one looks like. This is a test question. It's also a standardized test question. You remember the index card that I told you to make out with the girl, 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 and the boy, boy, boy? I told you where to find it on Google. Well, this is that question. And if you count out of the hold on a second. I believe you'll get boy, boy, girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, and girl, girl, boy. And that's 6 out of 8, which is 3 out of 4, which is 0.75. Now, if you didn't get that index card filled out, then you don't have any idea what I'm talking about. So 0.75. Let's see if I'm right. There you go. Simple question. Why do I like this one as a test question? Because it's short and what? Short and sweet. So there you go. So if you have your index card that I told you to fill out, then you understand it. If you don't have your index card, you have no idea what I'm talking about. Okay, Ms. Holder, does that help? I kidding. You didn't have your mic unmuted. I just saw your lips moving. Just hit the mic one time.
I just put it in and it said it was correct. So
okay. Do you have your index card?
No, which I put on my thing to make the index card.
Okay, well, just to make sure, because I don't want to leave you out, since you're trying today, since you're trying to communicate with me, I'm going to help you out.
Okay.
So just go up and look up. I look up children sample space. So write that down. And then hit images. And you can either copy or you can, put it in a Word document. Now, this one is the one I use. But you don't have to do the tree. You don't have to copy the tree. Just copy the, boy, boy, girl, boy, boy, all that. The one on the right. You don't need to copy the tree. And I would do it for 2 children, 3 children, and 4 children is in the book. But you can look it up on here. You should be able to find it. I think there's a 4 children on here somewhere, but you just got to look for it. But it's also in the book. So that'll help you out. Okay? All right, the next one. 7C as in Charlie, 19. And Mr. Justin sent this one. Number 8. Is it a test question? This is expected value. Now, I don't usually test on expected value, but those dadgum standardized tests, they test on expected value. So you got to learn it. Expected value, as I told you in the slides, you take the probability and multiply it by the result. So in this case, an insurance policy sells for $800. So for $800, that's one person. Okay, one person. And then $15,000 is 1 over 100. Oh, I'm sorry. Hold on. Let me move this down. Somebody's birds are going off. That's okay. I'd rather hear birds than dog barking. 1 over 100. And then, let's see, 40,000 would be 1 over 200. And then 60,000 would be 1 over 250. Now, one of the things you have to do with this problem is you have to put it in context. You're working for the insurance company. So what is the $800? If you pay $800 to an insurance company, how does the insurance company look at that $800? As a positive or a negative? If you're looking from the perspective of the insurance company.
Positive.
Positive. What about if they pay out $15,000, $40,000, and $60,000? What
Negative.
does the insurance company say about that?
It's negative.
Okay. And now you just do the math. So I'm going to do the math. And I'm going to get out my handy dandy calculator. And 800, might as well just do 800 plus parentheses negative 15,000 times 1 over 100 is 0.0. Let's see, that'd be tenths hundredths, 0.01, right? Plus parentheses negative. Let me make this a little bit bigger so you don't see what I'm doing. You'll like that, don't you? All right, negative 40,000 times 1 over 200, and you could do 1 over 200 in parentheses if you want to. 1 divided by 200, close parentheses, and then close parentheses, plus parentheses, negative 60,000 times parentheses 1 divided by 250, close parentheses, and hit enter, and you get $210. That's your expected value is equal to $210. Now, what if you spell, that's on each policy. What if you sell as an insurance agent? What if you sell 10,000 policies? Well, that would be 210 times 10,000. So take your handy dandy calculator and multiply by 10,000. And that is your expected profit. Should be, your expected profit is equal to 210 times 10,000 policies, and that's equal to, what did we say it was? 2.1 million. Ah, heck. Yeah, 2.1 million. And that's the expected profit. So I don't know what they're asking. The expected value is 210. The expected profit is 210 or 2.1 million. So you almost had it. You just got to add a few zeros. 1, 2, 3. There we go. And let's see if we're correct. It's a miracle. So that's the standardized test question. And I think somebody else sent another one. Or one like it. Here is 7C33/8. 33/8. I appreciate you writing notes on the bottom. Please go through this. You know, that's communication too. So I hope you don't get chastised too much for that. All right. The lottery posted the probabilities of winning each prize and the prize amounts as shown in the chart to the right. Suppose that one lottery ticket cost $1. Find the expected value of the winnings for a single ticket. Then state how much you would expect each year if you buy 10 lottery tickets per week. All right, so first of all, you got to look at the context. If you spend $1, is that positive or negative since you're looking at your pocketbook?
Negative.
So you're going to start with negative $1. And you're going to multiply 2 million times 1 over 10 million and 1 plus 200,000 times 1 over 50 million and 1 plus 2,000, and all these are positive because if you're looking from your context, if you win the lottery, that's positives. 1 over 25 there you go. Mr. King, are you a diehard Braves fan?
I wouldn't say diehard, but I am a Braves fan.
My father,
More of a Celtics.
bless his
fan.
heart, he was a Braves fan, and he used to watch the Braves. He used to get the channel that had the Braves on it, and every year he would say, just like Atlanta does, Atlanta Falcons, they choked, they choked, they choked. Every year he would say that. That's why I asked you if you were a diehard Braves fan. Something about Atlanta, I don't know what it is. University of Georgia, I'm a Dogs fan. I love Georgia ever since I was a kid. I got 3 degrees from Clemson, but I wanted to go to Georgia and be a veterinarian, but that didn't work out. Anyway, they choke, and Braves choke, and Falcons choke. So the Hawks, they don't even get a chance to go, I don't think. But anyway, I'm pretty much an Atlanta fan. So, all right, I'll shut up. I don't want to communicate too much.
Every
All right,
Georgia
so
team
if you
choked.
add all that up, I have no idea what you come up with, but we're fixing to do it. So clear and clear. And here we go. I like to start, I'm a little bit OCD. I don't like to start with a bunch of stuff over here. So -1 plus parentheses 2 million 1, 2, 3, 4, 5, 6 times parentheses 1 divided by 10 million and 1. Everybody with me? Plus parentheses. No, wait a minute. It's got to be 2 parentheses. Sorry, let me go back. 2 parentheses plus parentheses 200,000 times 1 over 50 million parentheses 1 divided by 50 million. Those zeros run together, so I'm hopefully, let's see, 1, 2, 3. Dadgummit. 1, 2, 3. I think that's right. I have to cover up the zeros because do y'all notice when you write millions, they start to run together, or is that just me? Plus 2,000 parentheses 2,000 times parentheses 1 divided by 25 million and 1. 1, 2, 3, 4, 5, 1. And that should equal your expected value. So your expected value for every dollar you spend on a ticket, your expected value is negative 80 cents. So what does that mean? That means for every ticket you buy, you've got an 80% chance of losing. Okay, pretty much. Now, what does it say after that? I don't know. Oh, how many tickets? Now, I'm not going to go through the unit conversion because all of you are pretty good students, even though you don't communicate. What is 10 times 52?
500.
So
5,010.
520.
100.
Yeah, you're going to multiply 520 times that expected value. So I'm going to multiply that by 520. So that's 520 tickets. Negative, that means you ain't going to win. Negative $413.88. So you're pretty much, are you playing to win or are you playing for fun? You're playing for fun because the expected value tells you that you got an 80% chance of losing with each ticket. And then this tells you that if you spend $520 on lottery tickets, you're only going to win maybe $73, or let's say $77 or $87. You're not going to win very much money. Let's add 520 to that and see what we get. So in a year's time, you might win $106. You might. So what's the expected value? The expected value is round to the nearest cent. So I did that. That'd be negative 80 cents. Negative, I don't know if they want a decimal. I think they do want a decimal. I don't know if that's what they want or not. Let's see what they want. They got 98. Okay, I must have done something wrong. Somebody check my math. Did anybody else get 98? I got 80.
I think you did 10 million when it was supposed to be 100 million for the first one.
Okay, all right, thank you. Yeah, you're right. I did 10 million. Right here, so everybody can see I screwed up. Right here, I did 10 million, and thank you for whoever said that. Who said that? Okay, that's okay. I understand if you don't want to say. You don't want to get beat up. I understand. That's okay. All right. So that's supposed to be 100 million. So it comes out to 98. So let's multiply the 98, since I screwed that up. Let's multiply the 98.98, negative 0.98, negative 0.98 times 520. Negative 509. So negative 509, that's supposed to be 0.98. Negative 509.6. So that's even worse. So that means for every year that you spend $520, you're going to win $10. You suck. So 509.6 is your expected profit. So let's see what they want. So you can expect to lose $509, and that's round to the nearest cent, 509.6. Okay? So you pretty much, you would expect to win or lose this amount because I don't understand what they're asking here. You would expect to win or lose this amount because some combination of prizes, no combination. you would expect to win or lose this amount because no combination. I have no idea why they're asking this question. And I got it wrong. Let's see. The answer is you would not. Oh, you would not expect. I don't understand how you would not expect to win or lose. Do y'all understand that? How could
No.
you not expect to win or lose? I don't understand this question. I could understand it if it said you would not expect to lose or you would not expect to win. I could understand that. But how do you not expect to win or lose?
Maybe because it's you can't predict what's gonna happen.
Yeah, I guess, but I think the wording of this question, I did
It's
get that right.
confusing.
Now, yeah, it is confusing. Now, this is not confusing because this does not equal none of your, so that's why that it says no combination of prizes equals that amount. So that's why this does not equal any of the prizes. So that's why I put that. But this right here, would not expect to win or lose is like being pregnant and not being pregnant at the same time. I mean, I don't understand how you would say would not expect to win or lose. I think they need to reword that. I mean, that needs to be reworded. It just does not. That first
Definitely.
part of that sentence don't make sense. What?
It definitely needs to be reworded.
Yeah, I don't like this one as a test question at all. If I were to put an expected value, it would be the insurance question. Why the insurance question? Because that's the one that's on standardized test. Okay. So if I was to do and I don't like this one, I like the first two questions. This Philadelphia lawyer question, I don't like it. And if you don't know what a Philadelphia lawyer means, that means down around here where I grew up, if something was confusing, like a contract or something like that, it'd take a Philadelphia lawyer to figure it out. And I don't know where the Philadelphia lawyer came from. I don't know if that's an old timey saying or what, but that's what I grew up hearing. So I don't know. So I hope I didn't offend anybody from Philadelphia. You know, Dr. Seuss and Mr. Potato Head. I hope I didn't offend anybody. My God. United States of buttercups and daisies. All right, here's another one. Justin, do you feel okay on that, or you want me to go over yours too? You feel okay?
On which one?
This
On the
one
one
right
we
here,
just
that's
went
the
over?
same one.
Oh, I don't remember which one that is.
Yeah, that's the same one we just went over.
Oh, yeah,
Yeah.
I feel more comfortable
You're
with that.
good?
Yeah.
Okay. Besides, I don't want to do that one again. That sucked.
Yeah.
All right. 7E. Ooh, 7E. This must be factorial. And let's go to that one and see what it says. 7 factorial. Well, 7. Now I want to ask you, there's 2 ways to do this question. One is on the calculator. The other one is by hand. 7 times 6 times 4, 5 times 4 times 3 times 2 times 1. 7 factorial. Well, 7 times 6 is 42. 42 times 5, hold on, 210. Somebody help me out there. 210 times 4 is 440. 440 times 3 is 1420. I may be totally wrong. Yeah, I'm way off there.
It's 5,040.
Well, I know it's 5,040. I'm just trying to get there. All right, 7 times 6 is 42. 42 times 5. It's not 210, is it? 42 times 5? 42 times 5. Yeah, it should be 210. There it is. 210 is not 440, it's 8. 840. 840 times 3 is 2520. And 2520 times 2 is 5040. Now that's how you do it by hand. If you want to do it on a calculator, which I showed y'all the other day, nobody was listening, take your handy dandy calculator and do 7 math, probability, and 4. It's a miracle. Now, that's all the homework questions. Who's got questions? Anybody got any comments, question?
I have a question. I don't think I sent it in on the homework, but I thought I did. It's on the it's on 7E as well.
Send it to me right quick. Good.
Right.
You got a second to go look for it?
Yeah, I found it. I've sent it.
Yeah, it just came in. That's some real hard work there, I tell you. And by some of y'all's grades on y'all's homework, I think some of y'all need to be doing it. Some of you need to be sending more questions, but that's just me. All right, 7A. You got one. Okay, good. Mr. Curtis sent one. 7A, 2414. And then we'll get to yours. Determine the probability of having 1 girl and 3 boys in a 4-child family. Now, I'm going to go and pull up the 4-child. We went over that, and you were supposed to put it in a index card. I take it you didn't do that, so I'm going to find it for you. Let's see. I think it's under here. And the only reason I'm pulling up the slide is because that's where they have the 4-child 1A. What chapter are we in? 7A? There we go. That's the only place I've seen it. I think there's one on Google, but I didn't see it when I looked at it a while ago. Let me find it. There it is.
You have a work email.
Remember me telling you to put this on your index card? Well, that's why I told you. There you go. Write it down. Give you a second chance. I shouldn't. But since y'all are communicating with me, I don't mind giving you a second chance. Hint, hint. I'm not going to explain that last comment, but maybe some of y'all can figure it out. All right. Girl, 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 girl. I'm not going to write all that out. Y'all can write it out, but this is the third one that you should put on your index card. And for those of you that don't remember what I'm talking about, I told you to take I don't know why I did that. I told you to take an index card and divide it into 3 sections. And I told you to put 2 children in the first one. I told you to put 3 children in the second one, and the 4th children on the last one. And that's my exact words with y'all. I think it was Monday. I told you to make sure you had an index card with those 3 on it. And there is 4 children. So let's go back to the question while y'all are writing.
Work email.
And let's see what it says again. It says, hold on, I'm trying to get both of them on here. Just bear with me a second. 1 girl, the probability of having 1 girl and 3 boys. All right, so let's look here. 1 girl and 3 boys. There it is. 1 girl and 3 boys. How many? 4? 1, 4. That's 10. What is it? 16? Yeah, there it is, 16. So it'd be 4 out of 16, which is 1/4, which is what? 0.25, Hubert. Well, I guess I didn't do it right. Let me do 1/4.
It's asking for an integer or a simplified fraction.
Oh my God. Now, that right there, if you did that on a test and it marked it wrong by 0.25, I would give you points on that. But try to read the directions so I don't have to change everybody's test. It says simplified fraction, but it should have took 0.25. But anyway, that's it. Now I'm going to put this back on here because I know there's some of y'all that didn't do what I told you to do. And I'm going to leave that on here for a few seconds. So you will hopefully fill that out. I told you it's a whole lot easier to have it on an index card than it is to try to figure it out. So I'm going to leave that there for a few seconds. And that was a test question, and it was a standardized test question. They love to ask about the 3 kids and 4 kids. They love to ask that question. All right. I can't leave it up there anymore, so you'll have to go to the video, which I know is awful for y'all to have to hit the video and pause it, and you can copy it down. Yes, you're welcome for doing the video, so you have that. Yes, you're welcome. All right. Oh my, look at there. 7E, well, that's 7A, so I'll get rid of that one. Here's 7C, so let's do 7C. Let's see, that's 23 and 38. 23, let's see what it says. This is question number 10. Suppose you play a coin toss game in which you win $1 if a head appears and lose $1 if a tail appears. If the first 100 coin tosses, heads come up 41 times and tails comes up 59 times. Answer part A through D. Okay, well, that's pretty simple. 41 times, what percentage of heads? That'd be 41%. That's not difficult. You've won $18, and that would be what? How would you do that? Let's see. What does it say? Yeah. And how'd you come up with the $18, Miss Holder?
Do you want me to go back through my work?
No, I mean, you just basically multiplied. Tell them how you got that.
It was 41 minus 59, and it was negative 18.
Mm-hmm. That's right. Good. Loss and wins. This is just like cost and revenue. All right. Suppose that you toss the coin 200 more times, a total of 300 tosses, and at that point has come up 42% of the time. Heads come up 42%. Is this change in percentage of heads consistent with the law of large numbers? And so you already got that correct. The change is consistent with the law of large numbers because as the number of trials increase, the proportion should grow closer to 50. I told y'all that last week or Monday. What is the law of large numbers? The law of large numbers, the physical probability gets closer and closer to the theoretical probability as you go up. So yes, going to 300 tosses would increase your probability. What is the net gain? And that would be 48 because you would subtract it. Okay, how many heads would you need in the next 100 tosses in order to break even? Well, what would break even be?
It'd be 200 heads and 200 tails.
That would be break even. Is this likely to occur? I doubt it. Not with 400 tosses, but anyway, let's see, how many heads would you need in the next 100 tosses? That would be 400. Select the correct choice. You would need a toss of 200 heads at least, wouldn't it? I would think. No. 74. Let me see where they're getting the 74. They're getting 74 from percentage. Suppose you toss the tilt coin 200 more times, a total of 300 tosses, and the cost of 42%. Let me read the question again. How many heads would you need in the next 100 tosses in order to break even after 400 tosses? Oh, 74 out of 100. Because, let's see. You've already here, you got 300 tosses. So 300 times 42, yeah, that's where they're getting that from. 300 times 42, I would assume 300 times 0.42 is equal to 126. That's where they're getting it from. Minus 100, minus 200. There it is. That's why. That's where they're getting it. All right, right here, 42% of the 300 tosses. You got that? 42% of 300. You add another 100, it's equal to 200. We were thinking 200, but we've already tossed it 300 times, and 42 were heads. So how many more added to the heads? And that's where the 74. And that's what I just did right here. So you got 300 tosses and 42%. That's 126 heads. So how many, we said 200 was breaking even. How many would you need to get to break even? And that would be 74, because 74 plus 126 is 200. This is a yucky question, Ms. Holder. I can understand why you sent it. Suppose that, still behind after 400 tosses, you decide to keep playing because you are due. That's not, put an X through that. Nobody is due anything. When you're talking about games of chance, you either at the right place at the right time or you're not. There is no, I'm due some luck. No, there is no such thing. All right. Explain how this belief would illustrate the gambler's fallacy. Well, any one of them, when it says that I'm going to keep playing because I'm due for my luck to change. No, due, you take out the word due. And I don't know which one says that the best. This illustrates the gambler's fallacy because the probability of getting heads is always 0.5. This illustrates the gambler's fallacy because eventually there will be a winning streak. No, B is not the answer. What is it? What's so funny?
I just think that's really funny that you don't believe in this guy, and you're like, yeah, he's never gonna win.
This illustrates a gambler's fallacy because due to the law of large numbers, the probability of getting heads must now be more. No, you're no. This illustrates the gambler's fallacy because the number of heads cannot be under 50% all the time. I have no earthly idea which one the answer is. I'm going to be honest with you. So some of you, we know it's not B because there is no, eventually there will be a winning streak. Watch it be B. I'm going to pick B. I knew it wasn't B. All right. So let's see. I don't think it's C.
Shouldn't it be A?
I don't think, yeah,
I think
it may
it's
be A. But because the probability of getting hit is always, I would say A because that's the only true statement. This is the only true statement. The other statements are false, especially these two. Eventually, there will be a winning streak. Oh, that would be a hail to the no. And this one, now be more than no. The probability will never be more unless you're using a loaded coin. And this one says, because the number of heads cannot be under 50% all the time. No, that's not true either, because you could actually be over 50% with, heads, but it's not going to be all the time unless you got a loaded die. I mean, a loaded coin. So I guess the only true statement would be this one. Now, I don't know. I may be totally wrong. And that's it. This is not a test question. I'm telling you that right now. One, it's got too many parts. And two, it tries to confuse you. It doesn't teach you anything. I don't think it does, but that's just me. All right, next question. Take that one out. And let's see if this is, this one is 38. So let's take that one out. And let's do 38. This is 38/14. In the game of roulette, when a player gives a casino $2 for a bet on the number 21, the player has a 37 to 38 probability of losing. Okay, so probability against, I'm just going to write this down, is 37 over 38. Therefore, the probability of that's probability of losing. Right? The probability of winning is equal to 1 over 38. So that's the probability of success, and that's the probability of failure. Let's see what else it says. Probability of making a net gain of $70. The price is $72, but the player's $2 bet is not returned. So the net gain is 70. If a player bets, this is totally outrageous question. If a player bets $2 that the outcome is an odd number, the probability of losing, okay, odd number, and this is just numbers. I'm having to write all this down because this is a ridiculous question. It's too long. The probability of losing is, so the probability of failure is 20 over 38. Probability of failure is 20 over 38. Therefore, the probability of success is equal to 18 over 38. When are they ever going to get to the freaking question? If a player bets $2 on an odd number and win, the player is given $4. That includes the bet, so the net gain is $2. Complete parts A through C. Good golly molly. I can see why you sent this question. This is a stupid question. If a player bets $2 on number 21, what is the player's expected value? Oh my God. All right, so the player 21, that you got the probability here and here. So let me just do this. Here's your probabilities. I don't know why this thing is not automatically, supposed to be automatically focusing. And it's not. So this is what they already give you right here. They give you the probability of failure on just a number, 21, is 37 over 38. The probability of success is 1 over 38, and that's just with the number 21. And then an odd number, the probability of failure is 20 over 38, and the probability of success is 18 over 38. Now you just got to have your situation. Okay, let's see what the situation is. You bet, and this is very difficult. Let's see. In the game of roulette, probability of losing $2 and 138 probability of a net gain of $70. The prize is $72. Okay, so that would be 72. That's your probability of losing would be 2. So that would be 2 times 37 over 38 plus 70 times 1 over 38. So that would be the expected value there. I just assuming what they were. Okay, so 37 over 38 would be times 2, $2. And then 1 over 38 would be times $70. And that would give you the expected value of 21. Okay, with the odd number. Well, that's going to be probability of losing $2 on the odd number would be 2 times 20. So that would be 2 times 20. And I'm looking to see what else they give you. And 2 times 18. And that should be the expected value for B. Okay. That would be how you do that problem. I'm going to have to move on because Mr. Justin sent his question in and I hadn't got to it yet. So let me get to that one. I'm not trying to skip it, but that's what that one should be. So let's go to the next one. And there is Mr. Justin's question, 7E 53/18. And I got to hurry. I only got a minute, and some of y'all will self-combust. Find the probability of being dealt 5 cards from a standard deck and getting 3 of a kind and not a superior poker hand. Whatever. Okay, 3 of a kind. So that would be, you're going to use, let's see, 3 of a kind. That's like an ace, and an ace. We're just thinking, okay? Now, the good thing about the cards is there's 1 of each card. So 3 of a kind would be like 3 aces. How many aces are in a deck of cards?
4.
4 out of 52. Do you put the cards back, Mr. Justin? You playing poker? Do you put them back?
No.
No. So this is without what?
Without replacement.
Without replacement. This is the not Marlboros, the marbles. Remember the bag of marbles? I don't know if I showed y'all that or not. Did I show y'all the bag of marbles? Okay, I don't think I did. All right, times 3. Okay, there's 3 aces left. And how many cards are left in the deck, Mr. Justin? After 51. You've been dealt this 1 card.
51.
51. And then how many aces are left?
2.
Out of?
50.
50. And see, that's the same whether you do 3 aces or whether you do 3 kings or whether you do 3 queens. You ever tried to write and not look at your hand? It's kind of weird whenever you do it. 3 threes. There's a little bit of a delay. Give me another card. Jacks. Because there's 4 of every what? Of every card. Mm-hmm. So if you're wanting to find 3, 1, 2, 3, there they are. So 4 out of 52 times 3 over 51 times 2 over 50. And make sure you realize they're without replacement, which means dependent.
Mm-hmm.
Question. Right. Complaint.
I don't know. I didn't think that this was how to do it, but I guess it is.
Well, that's the way I would do it. Well, I may be wrong. You could do, let's see the probability of being dealt five cards from a standard deck and getting 3 of a kind. That may be like the flags. No, it's a combination. Okay. 52/5. But I don't see how you're going to do the three of a kind. I don't know how you're going to do that. There it is. Okay, they did it with combination. All right, I'll tell you what, I'll make a deal with y'all. Since y'all have made an effort to communicate, I'm going to extend the homework and the test to Wednesday. Okay, but I'm going to tell the class right now, you have Mr. Justin, Miss Holder, and Mr. Campbell to thank, because they have actually tried. And the other people that have sent homework questions, you are actually to thank for this, because now I see that you are having problems with certain questions, and I don't have enough time to do these 2 questions fully, so I'm leaving them. I'm not deleting them, and I will do them Monday for you. That's how class works, together. Not one teacher teaching all the time. Y'all been conditioned. I know y'all been conditioned. K through 12 conditions you, and I'm not K through 12. I'm out here to right field or left field. I'm by myself. You got to communicate with me. If you don't communicate with me, the class doesn't work. Okay? Now, I'm going to shut off the recording, and I'm going to go